reduction. Increasing vehicle numbers on the road causing overflows car in parking space and the drivers south to park anywhere they feel safe. This action will cause traffic congestion, double park and most importantly disruption for an emergency vehicle to pass through. So the vehicle integrated parking system is introduced to make parking system get more safe, technological and efficient for public use. These VIPs also require less surveillance with improving security and space-saving building. The objective of our group in producing this product is to design and fabricate vehicle integrated parking systems. Secondly, to perform product analysis of vehicle integrated parking systems. And last but not least, to test run and record data of the vehicle integrated parking systems. So this is our project scope, which is creating and fabricating 3 axis multi-level parking system to fully utilize the movement, thus reducing land area needed, to ease accessibility of finding parking spots in residential area, to provide safer parking spots for residents and to reduce trafficking and cruising time for residents. In this project, we have 6 problem statements consist of limited parking space, especially during break time. Second is high cruising time and different parking policies. Third is excessive automobile usage in residential areas. Fourth is car park are not from the surrounding residential area. Fifth is lack of information on which parking is available. And the last problem statement is safety concern due to outsiders. Now we are going to talk about literature review for the part of automated parking facility Eco Park. The Eco Park has an underground parking capacity of 50 or more automobiles. Therefore, the Eco Park, with an average retrieval time of 32 seconds, is a very efficient system. The average time it takes to drop off or collect a car is 32 seconds, which is extremely quick in the realm of mechanical parking. The Eco Park is an underground parking structure with automated parking and high capacity land is effectively utilized. For the towering parking system, it used the concept of multi-level towering building design that consume only 3 parking space. The design has the capacity for up to 60 cars with 45 sedans and 15 SUVs car. The advantage present is space-effective installation makes the parking possible in the space required for 3 cars. The car type allows SUV and sedan to park inside the building with the limitation weight max 2,200 kg. For the vertical rotary smart parking system, it can be said to be an economical system. This because in an area of 50 square meters can be built one set of lifting and sliding type mechanical parking equipment sets. Each can accommodate 13 vehicles, it's saving land construction. Customers can use PLC automatic control, a button or a swipe to complete the access car functions. This system is fast and can save customers time, so it is suitable for the transformation of public place, hospital, commercial areas and living area parking projects. Lift sliding mechanical parking system is one of the most useful parking products in the parking industry. The equipment has strong adaptability to the site and low requirements for civil works. It can build out of doors or in the basement of building. It has the following advantage, which is high space utilization, safe and reliable equipment, convenient vehicles access, easy to operate and maintain, and lower cost. Based on the research, we can identify and evaluate the customer requirement and the engineering characteristic for our design product. There are 5 points for customer requirement, which is easy accessibility to the parking spot, safer parking spot, weatherproof, convenience parking method, and less failure. For the engineering character, it is also consists of 5 points, which is an access card, limited access inside the system, resistant weather, automated drop and working parking system, and last is probability of failure. For the product design, number 1 is our project name, which is Vehicle Integrated Parking System or VIPs. Number 2, provide systematic automation and organized parking space. Number 3 is special features, which is accessible by using an access card or through smartphone application as alternatives. Drop and walk parking method, thief-proof. Number 4, key performance target, which is weatherproof, easy parking method, and lesser failure percentage. And the last point is number 5, which is user training required, is none. For the key project deadline is 6 months given to finalize the design and report. For the physical description, number 1, external dimension for the prototype, which is 910mm times to 450mm times to 470mm. Number 2 is compartment for each car, which is 70mm times to 110mm times to 90mm. And the material we use is plywood, aluminium and plastic. For the market identification, number 1, the target market for this product will be residential areas and hospitals. Number 2, expectancy of 1 to 2 years of market acceptance and expansion throughout the country in the 3rd year. Number 3, initial production for the actual product will be based on the number of pre-orders. Number 4, the brand name is Vehicle Integrated Parking System or VIPs. For the financial requirement, number 1, pricing policy over the life cycle. Target manufacturing cost is RM375.78. Estimate retail price is 40% higher than the target manufacturing cost. Number 2, the warranty policy, which is 5 years yearly inspection. Number 3 is expected financial performance or rate of return on investment is more than 20%. For the life cycle target, number 1, useful life and shelf life, more than 5 years expectancy. Number 2, cost of installation and operation, which is 985,100. For the maintenance schedule is yearly inspection and maintenance. Number 4, reliability, mean time to failure, which is 5 years. For the manufacturing specification, number 1, as for the prototype, all framing, electrical motor and gear components will be assembled in-house. For the suppliers is none. For the social, political and legal requirements, number 1, safety and environmental regulation will be followed. Number 2 is standards, research federal regulation on available land. Number 3, safety and product liability. The safety aspect in the maintenance of the final product will be revised and implemented. And the last is intellectual property. I will investigate the patent potential.
Assalamualaikum, my name is Haziq bin Musa. In this part, I will explain about manufacturing process. Firstly, we do part and component selection process. We choose the suitable material for every component and part, such as we pick plywood as a base, angle aluminium for guidance rail and many more. Secondly, we do grinding process, which is to cut the plywood, aluminium and other material with the desired specifications. After that, we smoothen every surface of material that have been cut by using varieties of sandpaper to look more neat. Next, we cut metals such as a shaft and metal materials by using hacksaw with the desired specification. Moreover, we use cordless drill for hole drilling, such as a hole for string that attach to shaft and a leaf. In joining process, we attach part and components such as leaf adhesives and plywood base by using super glue and hot glue gun. After joining process is done, we start to set up the coding and electronic part. For example, we use C++ software to programming our Arduino Uno, which is a microcontroller board. Finally, after all the process is done, we paint our project to look more neat and smart. This is our 3 main part, which is consists of parking slot for slotting car. Next, we have lift tower that function to lift up the car. Third, we have lift rail x-axis that to move lift in direction of x-axis. And this is our final design that we draw by using SolidWorks software. On left side, we have isometric view, and on right side, we have front view. And this is our final design that we draw by using SolidWorks software. On left side, we have isometric view, and on right side, we have front view. And lastly is exploded view.
Assalamualaikum. Thank you Haziq for passing the mic. For my slide, I'm going to explain on the calculation and analysis applied on the prototype. On finding the suitable component and load acting on it, I've used the formula to determine the suitable size for the motor specification. As for the lifting mechanism, we decide to use a 12-volt DC motor with the stated specifications. By using this formula, we found out that the required torque to pull the lift upward is within the range of the supplied torque. For the reacting force exerted that produced the inertia, we use the mass moment of inertia acted on the lift platform. By taking the moment about point A, we decided to consider any cross-section on the beam and the acting distance from point A. For the next slide, we calculated the beam reaction on the extend support rail using the previous formula and substitute the value into the moment formula. That's all from me. I'll be passing the next slide on impact to Shuhaida.
Assalamualaikum and hi, my name is Nur Shuhaida binti Azhar and I will talk about impact. As we know, some production processes have a negative impact on the environment. For example, is soldering process. In sectors that need the soldering of electronic components, exposure to solder vapors are unavoidable. The burning of rosin-based flux chemicals, which are generally used to establish electrical connections, produce solder vapors, which are hazardous to employees' health. Solder vapors from resin or colophony-based solder flux can result in a number of health issues, including occupational asthma. Asthma symptoms include coughing, shortness of breath, wheezing, and chest discomfort is one of the numerous dangers offered by flux gases. Next is allergic hypersensitivity. Allergic hypersensitivity is a frequent health concern that develops after a few months of exposure and can linger for years, producing wheezing and labored breathing. Lastly is irritation. Symptoms of direct or indirect contact with resin-based solder flux can vary from mild eye or nose irritation to more serious skin discoloration caused by airborne contact. We need efficient air management in order to manage the danger. Welding is a frequent procedure across a wide range of industries and locations. According to various estimates, welding operations employ between 0.2 and 2% of the working populations in industrialized nations. The fume and gases released during welding are hazardous to human health. The exposures may differ depending on whether the welding is done on a ship or in a confined area, in a workshop or outside in the open area. Welding fumes and gases can cause a variety of health problems, including hazards on respiratory system. This includes chronic bronchitis, interstitial lung disease, asthma, pneumoconiosis, lung cancer, and lung functions abnormalities. Secondly is hazards on kidney. Welders who have been exposed to heavy metals such as cadmium and nickel have reported kidney damage. Lastly is hazards on the visual systems. Photokeratitis and cataract can be caused by UV and infrared radiation emissions. Employers can pick the welding type for their manufacturing process based on its efficiency, weld quality, available equipment, and economics. For example, to reduce the risk of health concerns from welding. TIG welding, for example, produce less smoke than MMA, MIG, and FCAW procedures, making it a good choice for a welding operations. For economic reasons, the ideal and manufacturing method is one that provides the highest degree of general well-being while using the fewest resources and causing the least amount of environmental damage. There are several strategies to achieve a sustainable economy in the manufacturing process, including first one is boost worker productivity. It is accomplished through growing the skilled labor force, which is accomplished by employing only skilled employees to do the task since they are more efficient, and implement a training program for current employees so that they may learn new skills and become more efficient at their jobs. Second one is to lower the material cost. For information, materials are another key component of the manufacturing expenses. When raw material costs account for a large portion of your manufacturing costs, it makes sense to look for ways to cut them. The first step is to look for ways to save money on new materials. For example, buy big quantities of supplies to take advantage of supplier savings on bulk orders. Then, negotiate with numerous vendors and compare them to one another to guarantee to obtain the best price on the supplies. The third one is to reduce the number of materials used. Another strategy to improve economic sustainability is to utilize fewer resources in products. We can save money on materials if we can lower the amount of material that goes into a unit without sacrificing the product's quality. The fourth one is cut overhead costs. Overhead expenditures, which include electricity, office supplies, insurance, and other facility costs, are the costs connected with running the plant itself. Establish a clear overhead budget and look into different ways to save money. The fifth one is smart capital investment. Investing wisely on capital boosts efficiency. It is possible to minimize the overall cost of production by investing in efficient manufacturing machinery and tools. The sixth one is the preventive maintenance plans. Within the maintenance department, the strategy is to address the deployment of preventative and predictive maintenance. Develop a maintenance plan to keep all of the equipment in working order during plant shutdowns. The last one is keep inventory storage and purchasing under control. The higher the expense of warehousing for the makers, the longer the stock is stored. Manufacturers must have a good sense of when to resupply so that they are not stranded with excess or outmoded stocks in order to avoid this and lower the consequent overhead cost of production. Sustainable growth aims to strike a balance between social, economic, and environmental concerns. Sustainability and safety at their most fundamental level have the same goal in their mind, which is to save resources. Those resources are often thought of as environmental in the context of sustainability. The concept of sustainable development is to strike a balance between the three fundamental pillars of sustainability, which are economic, environmental, and social factors. When building the vehicle integrated parking system, the safety aspect was taken into consideration in accordance with the social sustainability aims in attaining sustainable development. Early in the design phase, safety in design is incorporated as a control measure to remove or reduce threats to health and safety throughout the product's life cycle. Component integration, safety features, and safe usage policies and procedures are some of the design factors that are taken into account while removing and minimizing risk and danger. The study of the interactions between people, our products, use systems, and the settings in which they work and live is known as human factors. Human factors design considers design for ease of maintenance and safety. In addition to use, individual workers' exposure to ergonomic risk factors was assessed using the Rapid Upper Limb Assessment, which is known as RULA.
Good days and hi, my name is Alistair Lambong, and today I will be presenting our prototype's cost analysis. From here, we can see is the component prices of the vehicle integrated parking systems prototype. The assembly, which consists of part name platform with a unit quantity of 6 units with a total cost of 51 ringgit. Next assembly is the lift tower, the lift, top rotating module, and lower rotating module, each with 1 unit respectively, with a total cost of 144 ringgit with 44 cents. And next is the assembly part of top rotating module support lower guide rail, and lower rotating module support with a total amount of 76 ringgit and 94 cents. And lastly is the operating system of our prototype with total amount of 76 ringgit and 10 cents. Therefore, the total amount and the actual amount cost of our prototype is 348 ringgit and 44 cents. From here is the break-even analysis table and graph that we gain from the actual cost of our prototype. Before we proceed to the break-even analysis, we assume that the ratio of our prototype value is equivalent to the 1 to the ratio of 348 ringgit and 44 cents to the ratio of 1 to the ratio of 3000 ringgit of actual real-life product size. From the break-even analysis table, for 1 unit of sales, we determine and set 1.2 million ringgit for our product sales with a variable cost of 869,000 ringgit, which cover the cost of electricity bills and water bills. Our contribution margins with a formula of product sales minus the product cost variable divided with our product sales and then multiply by 100%. Therefore, our contribution margins of our product is 27.58%. Next is our product's fixed cost, which covers the equipment and machines rental, salary for total 80 people, manufacturing costs, labor costs on material and part supplies, and transportation for material supply. The total of our fixed cost is 885,000 ringgit. Therefore, our total cost is 7,385,850 ringgit and net income with negative 6,250,850 ringgit. Below is the unit sales break-even analysis graph of our product. Therefore, we would need to sell at least 3 units in order to cover our fixed cost, which is also our break-even point, where the point is the total income of product equals the wild cost of the product. And if we sell our anticipated 5 units, then our profit will be 669,900 ringgit. As for discussion, we will compare between customers' requirement with our engineering characteristics of our product with our customer satisfactory survey. From this slide, you can see is the result of our Google Form survey after our prototype is fabricated with a total of 50 respondents. The first question is whether the current users are satisfied with the current parking system. Majority of the respondents answered no, which brings to the next problems where we ask the respondents how long does it take to find a parking spot in their residential areas, where more than 50% of the respondents answered more than 5 minutes. From this result, we can already achieve our customers' requirement where our product supply the ease of accessibility to the parking spot with the engineering characteristic of using an access card, which is RFID card as mentioned in our customers' requirements and engineering characteristics table. Next questions are, what do they think of the current problem of the current parking system, and what causes the parking spots in their area to be congested? Majority of respondents answered difficulties to finding parking spot and less parking slot provided by the authorities, at which our product customers' requirements has the convenience of parking method with an engineering characteristic of automated drop and walk parking system. Based on customers' requirement of our product also provides a safer parking spot as mentioned in the table, where in the third question of the survey, there are few percentage of the respondents mention safety method to the parking users. And lastly, from the survey of 50 respondents, we asked the respondents regarding the design, and 96% of the respondents agreed that this prototype will solve problems encountered in current parking system. Next is the results of performance analysis of our prototype. From here, we can take an example by slotting a car into compartment A, level 2, number 2, where our Arduino coding time was set at 7,000 milliseconds for rotational clockwise, and the actual time taken recorded was 7.03 seconds was the time taken to complete the rotational axis. Same procedures are repeated for X, Y, and Z axis, and we found out that each axis is slightly differs from the actual timing that was set and constructed in C++ software, as these may be caused by the weight of the load affecting the friction of the gear and ride mechanism. Therefore, the margin of error is too small, thus the prototype is considered working properly.
The next one is conclusion. So as a conclusion, we learned that working in a group can facilitate a given task or work. From the first day we started moving to complete this assignment, we often had a group discussions to create a division of tasks. That makes everything we do run smoothly because every member of the group has given a good cooperation during the success of this project. Moreover, this assignment has taught us to think creatively and innovatively because the goal of our group is to produce a new system that has never existed. Therefore, we have also learned how to use motors and gears to make movements on a part. Also, this project is a smart parking system is developed aiming at providing a less hassle and convenient to find parking slot, especially in residential areas. This initiative assists automobile drivers in parking their vehicles with the least amount of wasted time by providing reliable information on the availability of parking spaces. Features of this vehicle integrated parking system include RFID system to trigger the system, dual parking block compartment to fully utilize spaces with less lane wastage. In Malaysia, there is no parking system that uses radio frequency identification for their parking system. Since people are not familiar with RFID, so this prototype project is special compared to the other available smart parking system. Thus, the possibility of this vehicle integrated parking system to commercialize is high. That's all from our group. Thank you.